my dear students. My name is Neer Toyana. I am currently available at the Hamlet Tuition Center, Brahmatul, Kathmandu. If you want to contact me, my contact number is 9849 135739. Well, I'm also available at Kumudini Kunja Secondary School, Kalimati, Kathmandu, which was established in 2036 BS. And since its establishment, it has dedicated itself to knowledge and wisdom. Well, my dear students of grade 8, this is your science class, and we have been studying about lesson heat for previous few days, isn't it? And today is your last class regarding the lesson heat. Well, after our last class, we discussed about differences between heat and temperature, and then we discussed about kinetic theory of heat and temperature. We discussed about thermometer and its types, thermometric liquid, isn't it? And then we also mentioned that there are 3 different scales of measuring temperature, yes, and these scales are degree Celsius, yes, degree Celsius, degree Fahrenheit, and Kelvin. Okay, degree Celsius and degree Fahrenheit are conventional scales which has been on the earth for more than 1000 years. For thousands of years they have been in use, whereas Kelvin scale is relatively new scale, okay, which was introduced by scientists especially for experiments, okay, science experiments, for conducting science experiments. Well, Celsius scale, it was introduced by the French, okay, the French people introduced the Celsius scale, whereas Fahrenheit scale was introduced by British people. So Fahrenheit scale is a British system whereas Celsius scale is a French system. And definitely, being originated in 2 different parts of world without having any communication between these 2 communities, definitely they are going to have different scales or different values. Yes, in case of France, the minimum temperature they consider was 0 degrees Celsius, yes, and this is the temperature at which water freezes. They consider the temperature at which water freezes as 0 degrees Celsius. They consider it to be absolute 0, okay, and we already discussed that the temperature at which water freezes to ice is known as lower fixed point, or LFP, okay. In case of Celsius scale, it is set at 0 degrees Celsius, whereas in case of Fahrenheit, it is not set at 0, okay. It is very much possible that the British people set the minimum temperature that they encounter in their region as 0. They might have set something else as standard, not water, but something else as standard while setting 0 degree Fahrenheit, okay. That might be the minimum or the lowest temperature that they are experienced, okay. So 0 degree in Fahrenheit scale and 0 degree in Celsius scale are not same. They are not same, okay. However, the 0 degree Celsius in Celsius scale is actually same as 32 degree Fahrenheit in Fahrenheit scale, okay. 0 degree Celsius in Celsius scale is actually equals to 32 degree Fahrenheit in Fahrenheit scale, okay. So freezing point of water in British is already 32 degree above the minimum temperature they experience, okay. Okay, that's why they have different system, okay. Moreover, the temperature at which water boils is set at 100 degree in case of Celsius scale, okay, which is also known as upper fixed point. And in case of Fahrenheit scale, they have different standards, as I've already told you, okay. So in Fahrenheit scale, water boils at 212 degree Fahrenheit, okay. So you can say 100 degrees Celsius is equals to 212 degree Fahrenheit. And when you see the differences between lower fixed point and upper fixed point, you can observe that in Celsius scale, LFP and UFP is divided exactly into 100. Okay, that is why the French system, if you remember the MKS system, do you remember it or not? The MKS system. MKS system is also known as metric system. Okay, why is it called metric? Because everything is in the factor of 10, either 10 or 100 or 1000. Yes, like 1 kilogram equals to 1000 gram. Okay, 1 gram equals to 1000 milligram. 1 century, 100 years, 1 millennium, 1000 years. It's just like that. The point, in temperature scale also, LFP and UFP is divided into 100 equal parts, whereas in Fahrenheit scale it is divided into 180 parts. It's divided into 180 parts. Well, these were the traditional scales which are being used for measuring temperature. Okay. However, in scientific experiments, in papers, while conducting scientific experiments, use of several different forms or use of several different scales might be misleading. Okay, it might be misleading. Yes, that's why they need some different system which is not biased all over the world, which would not be biased all over the world. Now, if the scientist communities are to use Celsius scale, then they can say this is the point, 0 degree is the point at which water freezes, so it can be taken as minimum. But if they are to, those who argue for Fahrenheit scale, they might say that why water should be taken as standard? We can take something else as standard, and that something else actually freezes at 0 degree Fahrenheit, not at 0 degree Celsius. Okay, that's why Celsius scale is not standard, we must use Fahrenheit scale, they might say like that. Or if scientist community decided to use Fahrenheit scale, then the same type of argument might be made by those who argue for Celsius scale. Okay, that is a long debate to be settled. And moreover, what is to be taken as standard? There is another debate, either water or something else, or I don't know what is it the British system uses, but I know it's not water. Okay, so what is to be taken as standard? There is another debate as well. That's why what they did is they used liquid nitrogen as standard. The scientist community, they used what? They used liquid nitrogen as standard. Okay, and the temperature at which liquid nitrogen, well, wait, not liquid nitrogen. Okay, they used kinetic theory. Okay, they used kinetic theory to measure temperature, to make the scale of temperature. Okay, the temperature at which molecules absolutely do not vibrate. Okay, the temperature at which molecules absolutely do not vibrate is considered as 0 Kelvin. Okay, the temperature at which molecules absolutely do not vibrate is considered as 0 Kelvin. Okay, then they set up the scale. If the molecules have 1 joule energy, then the temperature is 1 Kelvin, 2 joule energy 2 Kelvin, and like that. Okay, like that. What it is found that the temperature at which water freezes is equivalent to 273 Kelvin. Okay, the temperature at which water freezes is equivalent to 273 Kelvin. Okay, that means even the ice, the molecules of ice are vibrating. Okay, even the molecules of ice are vibrating, and the temperature at which water starts to boil, it was found to be 373 Kelvin. Okay, so see the difference. In Kelvin scale also, LFP and UFP is divided into 100 equal parts. Okay, do you understand this table now? Well, now the relationship between Celsius, Fahrenheit and Kelvin would be C minus 0 by 100 is equals to F minus 32 by 180 equals to K minus 270, right? 100. Here, see the relation, how is it taken? C, the Celsius value minus lower fixed point divided by difference. See, this one and this one, these two informations are important for making this relation. Celsius value minus lower fixed point minus difference. Fahrenheit value minus LFP by difference. Kelvin scale or Kelvin degree minus 273 by difference. Okay, now how is this relation derived? That is not actually important part of your lesson, but still, if you are curious, I'm going to explain. Let us suppose that I need to take a temperature here at this point. Okay, in this scale, what I've shown in upper scale, I've shown you degree Celsius. In lower scale, I have shown you the Fahrenheit scale. Okay, degree Celsius starting from 0, Fahrenheit scale starting from 32. Yes, okay, 32 and ending to 212. Okay, so what I showed here exactly is the Celsius scale, the same scale between LFP and UFP. The Celsius scale is divided into 100 parts and Fahrenheit scale is divided into 180 parts. Now let's say I need to take a temperature right here. Okay, at this point I need to take temperature. Yes, let me show arrow for this. Okay, I need to express the temperature right here in terms of Celsius scale. In terms of Celsius scale, what is the temperature right here? 10, 20, 30, 40, 45. It is 45 degree Celsius. It is 45 degrees Celsius. And exactly at 45 degrees Celsius, what would be the temperature in Fahrenheit scale? Well, exactly at 45 degrees Celsius, what would be the temperature in Fahrenheit scale? Let's say the scale is okay, Y degree Fahrenheit. Let's say it is Y degree Fahrenheit. Okay, from this relation, what we can say is 45 degree Celsius is equals to Y degree Fahrenheit, isn't it? Celsius scale 45 degree Celsius is equals to Y degree Fahrenheit. We can say that. Is there any confusion? Well, now Celsius and Fahrenheit are not same thing, are they? They are not same value. So virtually saying, you cannot say that Celsius is equals to Fahrenheit. You cannot say this. Okay, so in terms of the exact value, I am going to take the fraction, the segment. Okay, the segment of the scale. If I take the segment of scale from here to here, if I take the segment of scale from here to here, then whether it is in Celsius scale or it is in Fahrenheit scale, does it matter? They are always same. They are equal, isn't it? This is also length and this is also length. If they are both length, okay, they are both length between same segment, then they must be equal. Now what is this segment? Well, this segment would be 45 minus 0. Yes, this segment would be 45 minus 0, whereas this segment would be Y minus 32, isn't it? Now that these two segments, they are actually equal. Yes, so you can write 45 degree Celsius minus 0. 0 is the lower fixed point. Yes, must be equals to Y degree Fahrenheit Okay, let's not write degree Fahrenheit now. Y minus 32. Got it? 45 minus 0 must be equals to y minus 32. This is actually what? Segment, isn't it? This is only what? Segment. Yes. Now once again I said that this length and this length, they are equal, but are they in standard terms? Are they in standard term? Definitely no, they are not in standard term. This is in terms of Celsius, this is in terms of Fahrenheit. Yes, this segment, it is not in centimeter or meter, is it? And this segment is also not in centimeter or meter. You cannot directly say 45 minus 0 equals to y minus 32. You cannot say that. Yes, because 45 minus 0 is in terms of Celsius, y minus 32 is in terms of Fahrenheit. Okay, now what makes them actually equal? What makes them expressible in terms of length is that how many segments are there? How many segments are there in the Celsius scale? Okay, we definitely know that from this much to this much segment is definitely equal in both scale, isn't it? Yes, that means in Celsius scale here we have 100 segment, in Fahrenheit scale we have 180 segment. So if you use unitary method, then what you find that 45 minus 0 segment is divided by 100. If you divide 45 minus 0, this 45 minus 0, this segment, if you divide it by 100, and okay, let me put a fraction over here. Okay, and similarly if you divide y minus 32, we have y minus 32 segment also, isn't it? If we divide y minus 32 by 180, because you know for the same length in Fahrenheit scale there are 180 segment. Okay, so if you divide y minus 32 by 180, then it is converted to, this segment is actually converted to length. Understood? Okay, so we can say now, okay, now we can say that this in terms of segment this might not be equal, yes, but if you convert it into actual length, you have already done that, isn't it? If you convert it into actual length, then this is equal. Okay, this much. This is how we got this relationship. Okay, this is how we got this relationship, in which now if you substitute this degree Celsius by simply C, okay, simply x, if you substitute this by x, then what you get? X minus 0 segment in Celsius is equals to y minus 32 segment in Fahrenheit. Okay, then x minus 0 by 100 segment would be equals to y minus 32 by 180 segment. Okay, now for our convention, for our ease of use, what we do, okay, I will copy this much. Okay, for our ease, we replace x by C. C stands for Celsius value, and y by F. F stands for Fahrenheit value. But once again, remember, in the value of C, you should never put degree Celsius. You should not put degree Celsius. Why? Because by using the segmentation method, we have already converted this degree Celsius into length, actual length. So C minus 0 by 100 actually represents a length. Okay, it does not represent degree Celsius, it represents a length. Okay, that's why while doing numerical, the value of C, you should never put degree Celsius there. simply put the value of Celsius scale. Okay, similarly, by using the same method, you can derive the relationship for Kelvin also. Okay, Kelvin value minus its lower fixed point 273 divided by total difference 100. Okay, this much. So don't forget this formula, this relation. This relationship is very important for doing numerical from this lesson. Okay, this much. Now let's do the numerical. Normal body temperature of human is 37 degrees Celsius. Convert it into Fahrenheit and Kelvin scale. Okay, let us convert it into Fahrenheit scale first. Here, you know that 37 degrees Celsius, isn't it? Okay, degree, I need to take from glyph. Okay, 37 degree Celsius is equals to how many degree Fahrenheit? We don't know. Yes. Okay, let's say x degree Fahrenheit. We know. We need to use the relationship, the same relationship. Okay, Celsius. Since we need to convert Celsius into Fahrenheit, we have to take the relationship of Celsius and Fahrenheit. Okay, Control C. Okay, I'm going to use this relationship here. Okay, now, or okay, I'm going to copy this. Now for Celsius scale, what we know, we are given it 37, isn't it? Our Celsius scale is 37. Yes. Okay, I have a problem here. The Celsius scale is 37, but do we know Fahrenheit scale? No, we do not know Fahrenheit scale. Let's put it x. Okay, 37 minus 0 by 100 equals to x minus 32 by 180. Or now you see 37 minus 0 means 37 itself. Yes, so it gives you 37 by 100 equals to x minus 32 by 180. Now by cross multiplying, if you do cross multiply, what you get? 37 by 100. Let's copy only this much. 37 by 100 into 180 is equals to x minus 32. Where is equals to? Okay, do you understand this step? I did what? I multiplied this 180 into here. Okay, by using cross multiplication method. Now if you do this in calculator, if you can, I suggest you do not use calculator, but still if you need to use calculator, then let's see what do you get. Well, what do we have? 37 divided by 100 is 0.37 in 7 into, we need to multiply it by 180, 66.6. Yes, so you get 66.6 is equals to x, okay, x minus, no, x minus 32. Yes, now you need to find the value of x, means this value must be cross over this equals to sign. Okay, if you take 32 into another side, then what will it be? 32 is actually subtracted in right side. Yes, that means in left side it will be added. Okay, 66 plus 32 is equals to x. Yes, therefore it gives us, okay, I have therefore sign over here, or do we have other sign? It says actually therefore. Okay, math symbols, let me see here. Do we have? No. Okay, let me pause and search. Okay, I didn't find it, so I'm going to use this one. Actually it is not the sign of therefore. Okay, therefore, or you can write x is equals to by adding this, what you get? 6 plus 3 9 and 6 plus 2 8, 98.6. So x equals to 98.6. Therefore that means, okay, that is, we can write that 37 degree, sorry, where is my degree? Here. Okay, 37 degree Celsius is equals to 98.6 degree Fahrenheit. Understood or not? Okay, this one. Is there any confusion? Well, don't write C. Okay, here I substitute f by x, yes, but sometimes what you do, you tend to write f without substituting, yes. You tend to write f here, no x, then f equals to 96 degree Fahrenheit, and then you tend to write the conclusion like what, f is equals to 98.6 degree Fahrenheit. You tend to write your answer like this, but this would be wrong. This would be wrong. Why? Because I have already told you the f in this relation, it has already been reduced into length. Okay, this f does not have any degree. Yes, that's why you cannot write f equals to 98.6 degree Fahrenheit. You cannot write it like that. Okay, that's why what I suggest that you always substitute f by x, so that this confusion would not arise, and then after you can simply substitute the value of x in this first equation. Got it? Okay, that's how you calculate. Okay, this is the first part of your numerical. Yes, it says it asks us to convert 37 degrees Celsius into both Fahrenheit and Kelvin scale. Okay, we have converted into Fahrenheit scale. Now we are going to convert it into Kelvin scale. Okay, here 37 degree. Okay, I need degree sign. I'll copy it from here instead of taking from graph. Okay, degree Celsius is equals to, once again, let's say y Kelvin. Okay, let's say y Kelvin. We do not know how many Kelvins are there in 37 degrees Celsius, and also point out that Kelvin does not have degree. Kelvin is simply a scale. Okay, we know now we need a relationship between Celsius and Kelvin, isn't it? That means we need to take this first and third relationship. We don't need second relationship. Okay, so anyway, I'm going to copy this and paste here. Okay, now I don't need this second relationship. Yes, I'm going to simply erase it. Okay, this is our relationship. Okay, or now I'm going to copy it so that I can put the value. I'm going to copy it from here, Control C, Control V. Now see, we have Celsius value. This is 37. Our Celsius value is 37. 37 minus 0 by 100. Yes, now okay, so 37 minus 0 means it will give you the same value. Okay, I'm going to copy it. Okay, see, 37 minus 0 is 37, isn't it? It will give us same value. Now what we can do, we have to cross multiply. We need to find out value of k, isn't it? We need to find out value of k. That means we need to isolate k. How can we do that? We have to we have to remove two of the terms, 273 and 100. We have to remove these two terms from this side to find out value of k, to isolate k. So among minus and divide, we have to separate 100 first. In this case, you have to go the reverse Budmash rule. Okay, so by cross multiplying 100 to other side, what we get, or you already have this, yes, 37 by 100 multiplied by 100 is equals to k minus 273, isn't it? Now 37 divided by 100 into 100 gives you 37 itself. So you have 37 equals to k minus 273. Okay, well, once again, instead of k, what we can write? Y. Yes. Okay, I almost forgot that. Okay, y minus 273. Now you can remove 273 from right side, and how can you do that? By adding it to left side is equals to y. Therefore it gives you a nice value. Yes, okay, therefore y is equals to 37 plus 273, 7 plus 3 10, carry over 1, and here we have 7, 7 plus 3 10, 10 plus 1 11, carry over 1, 1 plus 2 3, 310. We got the value of y as 310. If you want to use calculator, then 37 plus 273. Yes, okay, 37 plus 273, see, 310. We get 310. Okay, so from here we can write conclusion, that is 37 degrees Celsius. Again, once again I need a degree sign. Okay, 37 degree Celsius is equals to, by substituting value of y over here, you get 310 Kelvin. This much is your solution. Understood? Any confusion up here? Okay, then let's go to next question. At what temperature do Celsius scale and Fahrenheit scale give same reading? Okay, we need to find the temperature at which Celsius and Fahrenheit in both scale will have same reading. Like we know that at 0 degrees Celsius Fahrenheit reading will be 32. At 100 degrees Celsius Fahrenheit reading will be 212. So at what temperature do both Celsius and Fahrenheit scale have same reading? Okay, let us assume, we need to assume here x degree Celsius is equals to x degree Fahrenheit. Yes, that means x degree Celsius equals to x degree Fahrenheit means, look here, in both Celsius and Fahrenheit scale we have same reading, isn't it? That is x. We don't know it yet, but Celsius and Fahrenheit both scale have same reading, x. Now we need to find the value of x. Yes, so as we know, let's do this. You can do this. Yes, you have to do this. Yes. Okay, when somebody say like that to me, actually I get angry with the person who says like that. Okay, because they are actually disturbing in the thought process, thinking process. Okay, as we know, okay, we need the relationship between Celsius and Fahrenheit. Yes, so I'm going to copy the first and second relation. Okay, first and second relation, that means C minus 0 by 100 is equals to F minus 32 by 180. Or C, what is the value of C? What is the value of C? We know it is x degree Celsius equals to x degree Fahrenheit. Yes, that means value of C is x and value of F is also x. Okay, so after this what we can do, we can simply cross multiply. Yes, by doing cross multiply, by doing cross multiplication, what we get, okay, denominator from left side is multiplied to numerator and numerator from right side is multiplied to left side. Got it? 100 will be multiplied to x minus 32 and 180 will be multiplied to x minus 0. Okay, let's do this. So by cross multiplying like that, what you get, and whenever you do cross multiply, don't forget to put bracket, because 180 assumes that x minus 0 is a single term, but there actually are two terms. Okay, it assumes it as a single term, so we need to put a bracket. Okay, x minus 0 multiplied by 180 is equals to, in right side also, x minus 32 bracket close multiplied by 100. Okay, now say x minus 0 means x itself. Yes, so x into 180x, you can simply write it like this, 180x is equals to, now multiplying x minus 32 by 100, you know that if it is in bracket, 100 should be multiplied to both the terms. Okay, so by multiplying 100 to x, you get 100x. Okay, minus sign is still there, and by multiplying 100 to 32, you get 3200. Okay, so after this step, what we do, we need to put the terms having x to the same side. Okay, 180x and 100x, they are brothers. In terms of mathematics, they are brothers, but these two brothers are in different side. It should not be like that. Brothers should be on the same side, isn't it? Brothers should be on the same side, whatever is the matter. So what I'm going to do is, I'm going to bring the brothers together. So if 100x is shifted to another side, what will it be? It has positive sign, yes, and right side. Do not take the sign after it. Okay, take the sign before it. There are no sign means it has plus sign, and when that plus sign is taken to another side, it will be minus sign. Sorry, it will be minus sign like this. Okay, equals to, you have minus 3200 on this side. Okay, so what you get here, 180x minus 100x means 80x. Yes, equals to, no, okay, minus 3200. Okay, now how to find x? By isolating x. So to isolate x, what do you need to remove from here? 80. You need to remove 80 from this side. Okay, now see, 80 is actually multiplied to x. So if you take x to another side, then that 80 will be divided. Yes, okay, whenever I need to divide, I have to do something like this in this software. Okay, that is another limitation, but still this software is great. Okay, with other softwares that I have used so far to take your online class, well, this feature is available in none of them. Yes, I try to take it from OneNote. Okay, I try to take it from Microsoft Paint. I try to take it from PowerPoint, Microsoft PowerPoint, but none of them have this feature, and that is one of the things I like about this software InDesign. Actually, this is a software to design a book. Okay, but still I'm using it for presentation, for taking class, and people say that it is designed for, this software is made for designing book. Why are you using it for this purpose? Well, if I can use it for this purpose, then definitely I will use it for this purpose. It is just that simple. Okay, that is no need to make any complications. Okay, so 3200 divided by 80, it gives us 40. So you get the value of x as minus 40. Okay, that is, you can write the conclusion. You can write your conclusion by substituting the value of x over here. We say that x degree Celsius equals x degree Fahrenheit. That definitely means minus 40. Sorry, where is my degree? Okay, my degree is lost. I have to take it from here. Okay, minus 40 degree Celsius is equals to minus 40 degree Fahrenheit. Okay, this is your answer. Any confusion? Any confusion? This is simple mathematics, very simple mathematics. Okay, there is no complications in this solution. Okay, okay, this was. Now we have next question. Okay, I guess this question now you need to do on your own. Okay, this is your assignment. Convert 625 Kelvin into Celsius scale and Fahrenheit scale. Once again, to convert 625 Kelvin into Celsius scale, you need the relationship between Kelvin and Celsius. Yes, in that case you need to take first and third relation, Kelvin and Celsius. Okay, first and third. Okay, and in second part of question, you need to convert 625 Kelvin into Fahrenheit. That means you need a relationship between Kelvin and Fahrenheit. Okay, in that case, you can take the relationship second and third, Kelvin and Fahrenheit. You can take second and third relationships, okay, and then simply substitute the value and solve it. And once again, while starting, always start from 625 Kelvin equals to X degree Celsius, or 625 Kelvin equals to Y degree Fahrenheit. Always start from that, okay. Don't write 625 Kelvin equals to what. Don't write like that. Or some people even write it like this. It is absolutely incorrect. K equals to 625, okay, and C equals to what? Some people even write like this, and this is also absolutely wrong. Okay, why I am saying this is absolutely wrong? You do know that. You know that, yes? I'm saying this is wrong because in this relationship we are using here, C does not stand for degree Celsius, F does not stand for degree Fahrenheit, okay. This relationship, these are already converted into length, equivalent of length, okay. That's why there should be no degrees here, okay. So K equals to 65, C equals to what? That is absolutely not right. What you should write instead, 625 Kelvin is equals to X degree Celsius. You should write like this. Or regarding the next part of question, 600 Kelvin is equals to Y degree Fahrenheit. You should write like this, okay. And then there won't be any difficulty solving the question, okay. Okay, this was for today. All the best for solving this numerical. Actually, this is not very difficult. I don't need to say all the best, and yet I'm saying it. All the best for doing this numerical, okay. With this you will get the knowledge, okay, get the idea of how to convert one temperature from one scale to another scale, okay. So your lesson on heat concludes here. Now what you need to do, you have to submit the exercise from the textbook you have from the lesson heat, okay. Whichever publication you have, it does not matter. You can submit from any publication, okay. I am not very much specific about the publication, book publication, so you can use any publication book, okay. So whichever publication book you have, just complete the exercise from lesson heat and submit me, okay, through messenger, okay. This much for today. Thank you, class.